Let's go to page 55, and this is section 5.4, and this section is about modular arithmetic. Now, the modular arithmetic had to do with the remainder. So over here the paragraph says, imagine we decide to do all arithmetic in base 5. Doing arithmetic in different number base is not always easy. For example, you don't want to memorize a multiplication table for base 16. That means b times c equal to 84. So just to make it easier on ourselves, we will consider only the last digits. All the numbers have the same last digit in base 5 we consider equal. So for example, like 2 base 5 is equal to 12 base 5, equal to 22 base 5, equal to 32 base 5, equal dot dot dot. In base 10, this way looks like 2 equal to 7 equal to 12 equal to 17. The usual way to show that we are using this system is to replace the equal with a congruent. Okay, so 3 line means congruent. So instead of using equal, use 3 line to congruent. And append means add the suffix of mod 5. So with us, for example, 12 is congruent to 7 mod 5. We say that 12 is congruent to 7 mod 5. So what it's saying is that 12 divided by 5, okay, you can end up with a remainder of 7. Okay. Now this, and the way to do it is, for example, you go 12 divided by 5. You don't always have to put the maximum. You can just put 1. So 5 times 1 give you 5. And so you get, so 12 divided by 5, you can get remainder of 7. Okay. Which is also, so it means, again, when you're doing the modular arithmetic, right, think about the clock. Okay. And you go around the circle on the clock. So this clock, mod 5, means you have a clock, okay, and you have only 5 numbers. So you get 1, 2, 3, 4, 5. So you got 5 numbers on the clock. So 12 would be, so if you start from here, so you go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And so this will also equal to, congruent to 2 mod 5. Okay? So they are congruent. So again, this is a remainder. So you can, if you notice right over here, if you go 12 divided by 5, then you can go 2, so you get remainder of 2. Okay? Now with modular math, you don't always have to put the maximum number. You can put any number. For example, if you go -1, for example, okay, then you're going to get -5, and you're going to end up with 17. Okay? So this 12 is always congruent to, also congruent to 17 mod 5. Okay? Okay. So you can even use negative number. For example, let's use another example. So 12, 5, right? Let's say if you go 3 times 5 would be 15. So you get -3. Say, so 12 will also is congruent to -3 mod 5. Okay? So the way to do this is, again, you can keep adding 3, keep adding 5, so it's mod 5, means you keep, if you go going around the circle, if you're going this way, you keep adding 5. If you're going this way, you keep minusing 5. So you also can do this. Okay? So you keep going backward by 5. So they are all congruent. Okay. Now, let's go and do some example. Let's go to example 5.6. It says how many positive integers less than 100. Positive integer means starting with 1s, and less than 100 means 1 through 99 are congruent to, so you're looking for congruent to 3 mod 5. So how many numbers is equal? How many numbers are 3 mod 5? Okay. Now one way you can do it is by listing them. Okay. So 3. So you can start with 3 and then keep going by 5. So 3, 8, 13, okay, 18, and so forth. And then after you can count them. That's one way. Okay. Now the quicker way to do this is by just go and divide. So 1 through 99, so there are 99 numbers, you just divide by 5. So 1, so it would be 49, 9, 45, and 4. Now remainder is more than the 3, so you have to add 1. So when this is equal or more than that, you have to add 1. So answer would be there are 20 of them. Okay. Now let's do another example that is now on here. So how many, so let's say if you're doing from 50 to 250. So how many 3 mod 5 are in here? Okay. So in this case, what you need to do is you need to, so notice that you are missing 1 through 49. So to figure out this part over here, you need to go starting from 1 and always, so you start with 1 all the way to 250 and figure how many and minus this, you get that. Okay. So 1 through 49. So 1 through 49, let's divide by 5. Right? You want to do 3 mod 5, right? So you have to divide by 5. So 45, 4. Okay. Now again, now notice the remainder is bigger than the 3. So you have to add 1. So there are 10 of them in here. So there are 10 numbers from 1 to 49. Okay. Now we're going to do the same. From 1 to 250, we're going to divide. Okay. Now 0 is less than that, so whatever you get is fine. So there are 50. So there are 50 numbers that are 3 mod 5 from 1 to 250, and there are 10 from here to here. So that means this would be equal to 40. Okay. So you just use 50 minus that, you get that. Okay. But you always have to start with 1. Okay. So whenever you figure out whatever, you always have to start with 1. But this one does not start with 1, so you have to do this math. You have to figure out how many are in here. And you have to use this minus to get that. Now there are some things that you can add. Okay, so there are some principles. So if you go to page 57, your 12 is congruent to 7 mod 5. Okay, so now you can add on both sides. Okay, so you get 15 is congruent to 10 mod 5. And you can do the same for the multiplication. And you can also do it by square. Okay, so you got 12 is congruent to 7 mod 5. So if you square, you can square that. So now the 144 equal to 49 mod 5, and you can go in a circle, right? So 144. Okay, you can go in a cycle of 5, so this actually becomes 4 mod 5. Right? If you go in a cycle of, so you minus 45. You go 9 cycles of 5, so minus that, you get that. Okay, and you can check, right? 144 divided by 5, you should have a remainder of 4. Okay, now so on page 58, it gives you a warning. So division is much more complicated. So you have to divide. You have to be very careful. Okay. So just remember, division does not generally work in a modular arithmetic. Okay. So over here, on the paragraph right above the double line, it says in finding the last digit of the sum or product of two numbers, we don't need to do the entire sum or product. Just the sum of product of the last digits of two numbers. Okay? In math, this is reflected by the fact we can mark out before or after doing operations. The order doesn't matter. By this we mean that we can mark out the factor of the product and then multiply the result rather than having to mark out the product of the number. For example, okay, so I give you an example. It says 9899 is congruent to 4 mod 5, okay, and 7677 is congruent to 2 mod 5. Okay, so we can say that 9899 times by 7677, okay, this will equal to 4 times 2, okay, will equal to 8. So this will equal to 8 mod 5, right? 2 times 4 give you 8, and this will equal, this congruent to 3 mod 5. So that way you don't have to actually multiply out and then do the maths. Okay. Okay. So there are some rules that are very important rules that are on the bottom of the page 58. So 1, A plus C. So if A is congruent to B mod M, so if you add C on this side, this will apply. So you can do the addition. Okay. So you can add to both sides. And it's same, you can subtract same numbers on both sides. Okay, so again, if you start with this, so you can add a number to both sides, you can subtract a number to both sides, and you can multiply. Now, notice there's no division, so you have to be careful with the divisions. Okay, 4, you can do the exponents. Okay, so all these are true. The next one is you can distribute. So you have A plus B mod M. This will equal to 8 mod M plus B mod M. Okay, so if you have this kind of situation, you can kind of just distribute. Okay, number 6, if you have an AB mod M, so this will, in a way, it's like also the distribution. So this congruent. So it's congruent to A mod M times B mod M. Okay, so again, you can think of it like a distribution. Okay, now let's go to page 59 and example 5-7. It says if we're giving that A is congruent to 0 mod B, then the remainder when A is divided by B is 0. And so therefore, again, remember this is remainder, right? So when A divided by B, the remainder is 0. That means this can divide this exactly. That means B is a factor of A, and A is a multiple of B. Okay, so that's an important fact to realize. And you're going to use this to solve problems a lot. So this principle is used a lot. You want to get the Z equal to 0 mod something. Okay, that way this would be multiple of these.